So hello guys, welcome to the Algonics. Today we are solving the question of ICPC Regional 2018. The question named uh, a game of robots. Okay, so I have already read this question. So let me explain you by the examples and the questions. Okay, so in this question we are given a string of dots and numbers. The numbers can vary from 0 to 9, and the dots is also given in the string. Okay, so the dots means the empty spaces, and the numbers means the robots are present at that index, and the number on that particular index means the robot can move minus that range to plus that range. It means if we take an example from this question, let's take this example. Okay, so if we take this example, so this 2 can move minus 2 plus 2, and this 2 can move minus 2 plus 2. Okay, so this is the range of this robot and this robot. Let me explain you by another example. Let's say if there are three dots and here 4, 1, 2, 3, 4, 5, 6, 7, 8, and here's 2, and 1, 2, 3, and more. Okay, so this 4 can move minus 4 here to plus 4, and this 2 can move minus 2 here to plus 2. Okay, so this is the range of this robot, and this is the range of this robot. Okay, and also we have given that this if this robot can move from right, so 1, 2, 3, 4, this robot can move till here, and this 2 can move 1, 2 till here. So this is the last limit of this robot, and this is the last limit of this robot. Okay, so in this question we have asked that in the particular string we have to return if the situation situation of safe and unsafe. Okay, the states of safe and unsafe. Let me explain you the safe state first. Okay, so we are taking another example, dot 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 2, and dot 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 and 2, and dot dot dot. Okay, so in this example this 2 can move this and this plus 2, so this is the last limit of this robot, and minus 2, this robot can move minus 2 here, so 1 and 2, this is the last limit of this robot. Okay, so these both robots are not colliding with each other, so it's a state of safe, so we have to return here safe. And if we take another example, like 1, 2, 3, 4, dot 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 dot, and 1, 2, 3, and 3, dot dot dot. So this 4 can move minus 4 here, so this at that negative side, this is the last limit of this 4, and at the positive side, this is the last limit of this robot. Okay, so this robot 4 can move 1, 2, 3, and 4 plus 4, and this 3 can move minus 3 here, so 1, 2, 3, minus 3, and plus 3. Now we only have two robots, so we have to check between them. So let's say this is the last limit of 4, and this is the last limit of 3, so this is a they are not colliding with each other, so it's a safe state. Okay, now if we reduce the dots between them, 4, 1, 2, 3, 4, and again 3, dot dot dot, so this robot can move to till here, so this is the last limit of this robot, and this 3 can move 1, 2, 3, this is the last limit of 3, so actually this let me undo it, actually this, so they are crossing each other, it means they are colliding. So it's a unsafe state. So we have to return unsafe pair. Okay. Now I think you have understood the question. So how we can solve it? So my approach is to solve this question is, uh, let me explain you why this example and this example. So it's a safe state. So first let's take the safe state dot 4 dot 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 dot. Actually, pretty complex. 3, 4, 5, 6, 7, 8, and 3. Okay, and dot 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 dot. So this 4 can move till this limit, and this 3 can move till this limit. Okay, so it's a safe state as we already know. So how we can know that it's a safe state in the coding? So for it, 3 and the both number 3 and 4 can move safely when the sum of these two numbers are less than number of dots. Okay, the number of dots. Uh, let's here are the dots. Number of dots are 8, so they can move easily. And let's reduce the dots by 6. So 4 dot 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 4 and dot dot 3, 4, 5, 6 and 3 dot dot dot. So the number of dots are 6 here. So this 4 can move till here and this 3 can move till here. So they both are colliding. So it's unsafe state. So if the number of dots are less than the sum of both numbers, so it's a safe state. And if not, it's an unsafe state. Let's code it. So we are doing in code Ceph. So let's take input string. So we are given a string, and for storing the, and we have to make the sum of these two numbers. We don't need dots, so we only have to take these numbers. So we can store these numbers in our array list, and their index also. We can also use hash map for it, but at the beginner level, for the beginners, it's a little bit complex to use hash map. Rather than we can use array list to store value, and a different array list to store the index of that particular value. Okay, so let's make two array list. We have to go to templates. This is the array list for index, and this is, let's make it vr. Okay, we have to ignore the dots, so we can ignore them. So if is not dot, so we can store the values and whatever. So we are given as character, we are taking as character value, so we have to convert the character value to numeric value. So we are dot add uh, character numeric value of as that character, and we have to store the index also. So we are dot. Okay, so we have stored the values. Let me explain you one thing more. We have also given this string. Let me explain you this. So in this string, we can see here are only one robot present here. So this one robot can move anywhere he wants. Or so the answer of this robot is always yes. So this is the edge case we have to write here. So this edge case. So if we store this 2 in a array list, so we can know it by the array list size gonna be 1. So for checking it, if the AR dot size equals to 1, so save and continue from it. And if not, Okay, so in this loop we have to take values in a different variable. Into a equals to r dot get I, and into b. Why I'm taking b? Because we are taking this index. Let me hold up pen. We are taking this index and this index. So we have to play in these two values. So these two values are stored continuously in the array list. So we can access them by I and I plus 1. Okay. So let me write it down. So it's ar dot get I plus 1. Okay. Now we have to take indexes and one. Actually, it's an integer type. So into one, we have stored this in var array list. So var dot get I and into equals to I plus 1. Let's make the logic as we have done here. The logic is 4 plus 4 plus 3 should be less than the number of dots. Okay, so how we are calculating the number of dots here? So we have to calculate the indexes. So 0, 1, 2, 0, 1, 2, 3, and 4, 5, 6, 7, 8, 9, 10. So 10 minus 3, which will give us 7, and 7 minus 1, which because we are calculating the 0 index value, so 6 minus 1, so 6 is less than 7, so it's an unsafe state. Okay, let's make the logic. If actually we have to minus that value, 1 minus and 1 and minus 1 also is less than a plus v. So we have to return the value. Actually, it's a loop, so we can't return, or sorry, we can't print the value. So we have to make a boolean. Let's make it here. Because we are having moving through the I plus 1. So if we are in the last index, we can't go to I plus 1. So we have to move till I minus 1, the last index, the second last index. Boolean will be false and break. Okay, I think that's a loop. And print the values. If bool safe, and if not, it's unsafe. Let's run. Safe, safe, unsafe. I think it's not loading the last value. We have to run here. Safe, safe, unsafe, unsafe, safe, safe, unsafe, unsafe. Okay, let's submit it. Okay, we have to submit it in the practice. And here we go. Thank you.